is attentional amplification necessary for consciousness? So this question has been asked in various ways, and it remains one of the most controversial topics in the current consciousness research. And one of the key experimental paradigms is the dual task paradigm. And I'm going to explain that in this video. And in terms of the results, they are relatively clear, but what remains sort of controversial is the interpretations. So let's see what I mean by this. First, let's come back to this global neuronal workspace theory. So they say basically, without attentional amplification, it remains unconscious, right? When the top-down attention is absent, it's either subliminal or preconscious, meaning both, invisible or unreportable. And this model kind of explains the inattentional blindness and the change blindness and the attentional blink relatively well. And what about the dual task? That's the next question. So the dual task paradigm is the following. I already described the basic architecture. So, I'll start with the advantages of this dual task paradigm. It basically presents the stimulus in a far location. And so it induces minimum stimulus competition or interaction. So this is just to remind you what the dual task looks like. So typically, there is some kind of stimulus and the task at the center, and then here that exhausts all the attention. And then you are presented with some kind of stimulus at the periphery that may or may not require attention. And if you can do both central and the peripheral task, that means that the peripheral task does not require attention, but a central task sucks up all the attention. And if one of them can be done, but not both at the same time, then the peripheral stimulus or peripheral task requires some degree of attention. And then these two things do not need to interact spatially. It can be separated and so on. And that explains some of the advantage of the dual task design. So just to come back. So minimum stimulus confound wise that they allow identical stimuli in both attended and unattended conditions. So remember Bahrami's experiment. The difference between attended versus unattended is the only instruction, right? And the stimulus itself is coming to the brain in the same way. Dual task is basically that. So under the situation where you are doing only one task or the other, or both at the same time, stimulus input has to remain the same. You cannot do one task, showing only one task and then do it, and then another task and then do it, and then finally two at the same time, and then trying to do two at the same time. That's not great because it already introduces stimulus confound. Stimulus confound needs to be removed. All three conditions, you present a stimulus in the same way. And that also allows to disentangle many things, but one of the things is that minimizing the stimulus interaction. Let's say at the central task and the peripheral task, there is no interaction in between, and that's important to exclude various kind of effects such as crowding. So when things are presented at the same location, then it becomes invisible because of the interaction with this among the stimulus, and that itself can strongly interact with attention. So in the end, it allows dual task allows us to study one stimulus property at one time. But a change blindness experiment, for example, if you think about it, to make things invisible, you need to manipulate and so put the things into the context and then make it in a very complicated situation to make one stimulus either aware or unaware. So that's a very difficult task to study. Okay, and further, there are many more advantages, but another important thing, class of the advantage is that the flexibility in task design. What I mean, again, coming back to the Bahrami study, he was able to, independently manipulate attention and consciousness in the task design, right? So manipulating attention was done only with, central task relevance, easy task or difficult task, but without changing the stimulus. And then in terms of consciousness, in his case, he presented a continuous thrust suppression. And so, it does, interact with the stimulus compound itself, but you can imagine that presenting something like a Necker cube or binocular rivalry or a backward masking stimulus or whatever, where conscious visibility itself fluctuates, without changing the stimulus. And that kind of stuff can be done using the dual task paradigm, right? Presenting stimulus in a constant way, and sometimes it's visible, sometimes it's invisible. And then you can manipulate attention, and then paying attention or not. You can do this 2x2 design. And also it can be, the dual task can be combined to manipulate many different aspects of attention, or some process that are likely to interact with consciousness or attention. And that could include like inhibition, expectation, and memory, and so on. And importantly, this is important, but they are all possible to manipulate independently with respect to attention or consciousness on top of these two things. So for example, in the case of the expectation, that needs to be set up really properly in the case of inattentional blindness or change blindness, right? So if you tell the audience, about gorilla, expectation, then the gorilla inattention blindness can happen or not happen based on this instruction, but at the same time, it does affect on attention and also, consciousness. But under the dual task situation, you can tell the subjects about, expectation of the gorilla or not under poor or full attention situation, right? So that can be done in a disentangled manner. Memory, same, working memory or, other types of memory can be manipulated as well. And the inhibition wise, it's also possible to instruct to inhibit something or not while doing this task attentively or not, and consciousness can be manipulated. Attribute amnesia is also possible to do under this dual task conditions. Okay, so this is just a recap of the dual task paradigm. And then here is sort of a conceptual kind of summary of what we are looking for in terms of the trade-off between the two tasks. So first, you need to select and establish this primary task. And that itself needs to be difficult enough so that, if you do not pay full attention to this, then your performance goes down. So that's the kind of the task that you need to establish first. And in our case, it's usually, later tasks that sucks up the attention. And then if you don't pay attention to that, then its performance degrades. And then under this primary task, what we are truly interested is in attentional demands for the secondary task. So here, secondary task itself has to be also difficult enough, like 70% accuracy or 80% accuracy. And then the critical question is whether these two tasks are compatible or not, simultaneously possible to do here. In this case, this secondary task does not consume attention, and therefore primary task and secondary task can be performed at the same level as a single task situation. Remember that the stimulus input itself is the same, right? So at the top right is this no trade-off situation. Either tasks do not consume the limited attentional resource. Okay, or primary task completely consumed everything, but secondary task did not require much attention. The second thing is this complete trade-off, where if you need to choose one of the tasks, then the performance should line up on this diagonal line. The drop of the performance of the primary is compensated by the improvement of the performance of the secondary. And then there can be another case where it is intermediate between the top right and then anything in between at the bottom. So that's a sort of theoretical explanation of the dual task experiment. And it turned out that the previous study has repeatedly shown that the face gender discrimination, like here, female and also male, can be done without much, interference. So the central task is a letter task here, L versus T, and then that performance is normalized. So meaning that in the real performance wise, it's 70 or 80%, but for each individual subject, we they normalize it into the 100, and then compare that with the dual task situation. And the same goes for this, a peripheral performance. So in this case, it is a face gender discrimination. Under the single task, it's around here, and then it doesn't drop. But in the case of the red-green or green-red task, y-axis, then it's central task, single task performance locates here, but it all goes down here. If you try to do the same, LT task at the center at the same time. And many people, many experimenters usually are asked to prioritize this central task. So that's why you tend to see the clusters of the performance on the bottom right. But if they ask subjects to prioritize this one, then it would probably go up onto here. And if they divide a task, it's divide attention here. And in the case of the face task, regardless of the instruction on how to divide attention, most likely it's always around here. Okay. So that's the dual task results in the past. But here comes this, disadvantages of the dual task paradigm, and it's the criticism for many years actually. So one of the things is that it requires really long duration of the training before getting into the real experiment. I'll explain that next. And the second thing is that because training is really long, it's possible that excellent performance, like a face task, may be reflecting some kind of a non-conscious processing, but nobody has had a good answer to it. Okay. And then the third one is that it's just impossible to rule out the possibility that attention spills over to the stimuli outside of the focus of attention during dual task. Like Bahadur-Barami's experiment, neuronally, even if you're doing the task at the center, which is easy, still easy or difficult on the invisible stimulus outside, it gets either processed more or less depending on how much availability you have. So it's plausible that really difficult dual task experiment on the center may still remain make attentional availability to the periphery spilled over on in an unconscious manner, in a sense. So the first thing about traditional method wise. So here's results from 6 subjects in a particular experiment using the dual task face experiment. The strategy of the training of the subjects is the following, right? One is that training each participant, each of these participants first on the central task, and then just wait until their performance stabilizes at 80% accuracy. It may take like 1 hour or maybe 30 minutes, but it takes some time. And then, okay, now let's move on to the peripheral task. And then we set the stimulus parameter, and then we wait until that task performance reaches around 80%. Okay, now both of them get to 80%. Okay, let's start the experiment. That's not possible because we need to check whether the first one is actually still 80%. And then typically, after some delay or after some training duration, performance just drops or increases significantly. And therefore, you need to go back to establish the first task. And then while you're doing it, second task improves or drops. So you need to adjust it. And then typically, several days required until both two are kind of stabilized, and then people do not make a stupid kind of motor mistakes. And in the end, this kind of training procedure requires at least like 10 hours or so before the dual task data itself can start. And that limits a lot of conclusion about this dual task experiment. So what my previous PhD student, Julian Matthews, did was the following. So let's just shorten this training procedure. And also in addition, we also measure the metacognitive accuracy, which I'm going to talk about in the next video. So Julian's task looks like this. So after the standard presentation of dual task stimulus, we ask the response about same or different about the central task, or male or female about the peripheral task with this kind of display. And the subjects are going to click one of the locations to report both same, different, and also male, female, just 2 clicks, right? So for example, here, the next trial, this is all L plus T, so it was different. And I was confident, so I would just click the 4 different, right? And then let's focus on the peripheral phase, and then I would say that it was I think male and confident, so I would click only once. So this already saves the 2 responses into of the male or female and then confidence into 1 response. So instead of 4 responses, we can get 2 responses about both of the central and peripheral tasks, including the metacognition, and that saves a lot of time. And also, same kind of thing can be done for this, disk letter task as well, right? Both, central tasks and different plus confidence, and also red green disk, red green or green red plus confidence, 1 click at a time. Okay, and then we combined the quest staircase method to minimize the amount of the training. What is this quest method? So it's just a relatively simple kind of idea. When you make a correct judgment, the task becomes more difficult. And if you make a mistake, it becomes easier. And you may be familiar with this kind of thing in the quiz, right? So here, for example, this is a task that was done on the children who doesn't have long attentional span. So we want to, they want to also minimize the number of the training into several hours into just a couple of minutes. And then they started with an easy trial, like a 6%, and then 2 or 1. And then if it becomes too difficult, then they make a mistake, red, and then that moves up the difficulty and so on. And then this dark and bright green means 2 different kind of implementation, but both of the cases after 25 or 30 trials, they remain around here, meaning that their performance is most likely around certain area after several tens of trials. And by looking at specifically like around these areas of the performance, and then you selectively compute the performance here, then it turns out that okay, maybe the speed of difference of 1.5 corresponds to 80% accuracy. So instead of trying to establish and wait for the training to complete using this type of experiment, we can quickly get at this 80% accuracy line. And then so solution that Julian came up with was basically 1 click for each trial instead of 2 to get the confidence, and then continuously adjust the difficulty in the single task block. So rather than waiting for each of the things to stabilize, do that single task using this a staircase, and then another task again for the periphery, and then let's do the dual task right after that. And then in the next single task block, we again do this dual staircase, and for the peripheral task as well, and then do the dual task. So 3 blocks as 1 chunk, and then make sure that the training doesn't happen, or when the training effect happens and the subject improves, then we adjust the difficulty each block. And then that allows us to measure the task performance in the dual task with minimum training effect. And then eventually, what we achieved was that instead of this 10 hours of the training in a Reddy's study, in 2018, we were able to just minimize it into 10 to 15 minutes of the trial to do the dual task. And that basically replicated the finding for phase cases. In the phase cases, we found again the dual task performance is more or less a top right. On the other hand, the disk task here, it remained in the diagonal here. Both of these things. And the blue and the green dot, I'll explain it in the next video. Okay. So in summary, the effects of attention in consciousness need to be disentangled from various factors such as inhibition, expectation, memory, and many, many other things. The dual task paradigm is powerful in clearly separating contributions from stimuli, attention, and the consciousness. However, the dual task itself has limitations. But one of the limitations, at least in terms of training and lengthy duration, is solved already. And can we do the better? Can we do better thing with the dual task? That's the next question.